Here we are given the function u of x equals x times the square root of 4 minus x, and we're asked to find the local maximum value and the value at which that occurs, as well as the intervals on which the function is increasing and the interval on which it is decreasing. Before we graph this function, the theory will help us understand the graph that we will see. Notice that u of x is a product function, so the domain of u of x is the intersection of the domains of the function y equals x and y equals the square root of 4 minus x. For y equals x, the domain, the value of x can be any real number. But for the 4 minus square root of 4 minus x, we have a restriction. 4 minus x must be greater than or equal to 0. If I subtract 4 from both sides, I get the opposite of x is greater than or equal to negative 4. And if I divide both sides by negative 1 or multiply both sides by negative 1, I will get x is less than or equal to positive 4. Remember that when you multiply or divide by a negative number, you have to change the direction of the inequality. And so the intersection of the domains would in fact give us that the domain for u of x is x less than or equal to 4. Because for x it is all reals, and for the square root of 4 minus x, it's everything less than or equal to 4. So the intersection is also the values of x less than or equal to 4. So now let's go to the graphing calculator, and we'll enter x times the square root, which is a second square, of 4 minus x. And when we graph this in the standard window, it's a little hard to see what's happening. If I press trace and I go to the right, in this window, the last value of x that I see graphed is approximately 3.83, not actually 4. This is a problem with the distribution of the pixels on the screen and can be corrected by using a special zoom feature, zoom decimal. So I pressed the zoom key. Now I'm going to press 4 for decimal. And we get a slightly smaller window, but a window which does show us, if we press trace, that the graph is in fact defined at x equals 4. At x equals 4 it is 0. At x equals 4.1 there is no y value because 4.1 is not in the domain. And so this is what our graph looks like. We want to find the local maximum, so I'm going to press second trace, which gives me calc. Press 4. move the cursor back to the left of the local maximum. Hit enter. Move it again to the right of the local maximum. Hit enter twice. And we get that the local maximum is approximately at 2.67, and its value is 3.08. So I go back and I enter that the maximum is to 2 decimal places, 3.08. It occurs at 2.67. Both of these are captured by the point 2.67, 3.08. Just remember it's the 3.08 that is the maximum, the local maximum value, and the 2.67 tells you where that maximum occurs. So if we return to the graph, we see that the graph is increasing up to the local place where the local maximum occurs and decreasing thereafter. And so remember, we won't be able to say that it's decreasing between 2.67 and infinity because it's only defined up to 4. And so the interval in which the function is decreasing will end at x equals 4. So the increasing occurs from negative infinity to 2.67. Or with Stewart, negative infinity to 2.67, including the 2.67, and decreasing from 2.67 to 4.00, where the 4 is included. It is actually the end point of the domain. It could also be written with closed brackets. So we never use a closed bracket with infinity, but we do with the end values for increasing and decreasing in the Stewart textbook. Notice that 2.67 is both in the increasing interval and the decreasing interval if we use the square brackets.